Okay, so let's take a look at electrolytic cell. So here we have a diagram illustrating a typical electrolytic cell. This diagram contains a battery source. We have our anode and our cathode, and we have our electrolytes present here. So here it has a power source such as the battery. The battery is used as a power source to drive the chemical reaction in the way we want it to. It drives the reaction in a non-spontaneous direction. So imagine you're riding your bicycle. If you're riding your bicycle downhill, you don't need to put an extra power source, an extra energy. But if you're trying to go uphill, you're going to have to introduce pedal to the metal. You're going to have to push harder. So this is what we do when we in our electrolytic cell. We apply a power source. We're going in a direction which is non-spontaneous to the natural flow. So that's why we introduce our battery. We also have an electrode. We have two electrodes actually. We have an anode and a cathode. At the anode, we have oxidation, and at the cathode, we have reduction. Remember before we define oxidation and reduction in terms of electron. Oxidation is the loss of electron and reduction is the gain of electron. So we have and we also have free flowing ions. In this example, we have magnesium chloride in the pure form, the liquid format, molten state, and it dissociates, it breaks down to give magnesium 2 plus and Cl minus. So here we have our battery, and at the positive portion of the anode, we pull electrons towards the positive portion. The battery directs this electron towards the cathode. So we have our chlorine ion. Chlorine is very electronegative. It wouldn't want to lose an electron. But because of our battery source, we can force the chemical to behave in a way which is not the natural spontaneous direction. So we are forcing this chloride ion to release electron. So we have an oxidation taking place at the anode. So this electron is pulled towards the battery and is driven in this direction. And here we have our ions present. It goes through our electrode, and ions present anywhere around here will accept this electron to form the metal. So we have reduction taking place. So that's an overview of what takes place in an electrolytic cell. Another important thing is we have to look at the application of electrolytic cells. Electrolytic cells are used to generate chemical substances. It's also used to purify metals, and we also use it to coat surface, electroplating. This is one of the most common use of electrolysis. So if we want to electroplate this spoon, here we have a spoon, we want to electroplate the spoon, we have to make sure that the thing we want to be electroplated is placed at the cathode. And what we want to electroplate it with is placed at the anode. Okay, electrolysis can be used to electroplate metals with a surface. So if we want a chrome rim, we put our rim here at the cathode and we'll have our chrome metal here. So we'll have our electrons being drawn out, creating the plus charge. And the plus charge here and plus charge here repel. So the plus charge will migrate all the way over to the cathode. And since we're attracting electrons here, we're going to have the metals form and coat this entire surface. This is a very important application. So in this case here, the anode is itself a piece of silver. As the silver ions are produced by oxidation, they travel through the solution to the cathode. And at the cathode, they are reduced back to the silver atom and they stick to the metal being plated. I hope this provides some guidance into electrolysis.